Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 5.2.3, which is solving and applying quadratic equations. Now, in the past, we have done solving and applying quadratic equations using the water balloon problem. If you remember a couple lessons ago, there was impeccable and mags and all them. And that parabolic motion was able to tell us where the balloon was launched from, how high up it went, and where the balloon landed. These examples that I'm going to give to you guys today are going to be less direct quadratic equations. People aren't going to see them as quadratic equations in the beginning, but nevertheless, a quadratic equation is definitely going to apply. So when you see the relationship, it will hopefully make sense. We're going to begin with problem 5-108, and it reads, Gabby is working on another backyard project. She's building a fence to keep deer out of her garden. One side of her garden is up against a wall, so she will only need to build 3 sides of a fence. She has she has 100 feet of fencing, and she needs to enclose 600 square foot area. And what should the length and width of her fence be? So, to start off, we know that Gabby's wall is right here, and she's going to be building a fence that has only 3 sides. And so I'll go ahead and just draw this figure right here. And so what we do know is that the 3 sides in total are going to sum up to be 100 feet. Now, the way we generally find the area of something, the area could be considered the length times the width. Now, I'll go ahead and just call this side x, and I'll call this side y. Now, the area is going to be equal to x times y, but we also know that the area has to encapture 600 feet. So hopefully it makes sense that x times y is equal to 600. The problem with this, though, right now is that I don't know what x nor y is. So I'm going to have to figure out how can I manipulate one into the other. So the way I do that is I use the fact that she has 100 feet of fencing. So here's what I know. I know that since this side here on the left is y, this side on the right here is also y. So how can I use that information to my advantage? Well, I know that if I add up the 2 y's along with an x, I'm going to have in total 100 feet of fencing. So I'm going to use that to get x by itself. And I can say now that x is equal to 100 minus 2y. So how does that help me? Well, this piece of information here allows me to plug into my area formula. So instead of 600 equaling 2 variables, I now have 600 equaling 100 minus 2y times y. I have only one variable now. And when I have only one equation to work with, I can only solve for one variable at a time. So now that I've got the area in terms of just y, what I'm going to do is I'm going to distribute that y in. And I get 100y minus 2y squared is equal to 600. First thing to note is that we've got 600, 100, and 2. They're all even numbers. So what I'm going to do is I'm literally going to divide each piece on both sides of the equal sign by 2. So I get 300 is equal to 50y minus y squared. Now that step wasn't absolutely necessary, but I like to reduce my numbers because smaller numbers are generally easier to work with than larger numbers. So now that I have my quadratic equation, let's figure out how we can solve this. Generally speaking, my personal style is to make sure that the y squared term is positive. So the way I'm going to do that is I'm going to go ahead and add y squared to both sides. That's going to get me y squared plus 300 is equal to 50y. And as we've been talking about these last couple lessons, the quadratic equations that we've been learning are solvable when the quadratic is equal to 0. So I'll go ahead and do that. Y squared minus 50y plus 300 is equal to 0. So now I've got myself set up to solve this quadratic equation using the quadratic formula. Now technically I could use completing the square because the leading coefficient of the y squared is 1 and the middle term is even, but I'll just go and go for the quadratic formula. It's the last thing that we've learned, so I'll go and show you what that looks like. So I'll go and do it over here in this black empty space right here. So from here, in the context of this problem here, a would be 1. Again, that's the coefficient in front of the y squared. B would equal negative 50. That's the coefficient in front of the second term. And then C would equal 300. And so now from here, I would say y is equal to negative blank plus or minus the square root of a blank squared minus 4 times 2 blanks, all over 2 times a blank. And now it's just a matter of plugging the pieces in from the quadratic formula. So that is going to be, looks like negative 50 squared, 4a, so that's 1, 300 is c, all over 2 times 1. So after simplifying it all out, you get y equals negative 50 is 50, plus or minus the square root of 50 squared is 2500, minus 4 times 300 is 1200, all over 2. And so now from here, I'll go and scroll down. So from here, I've got 50 plus or minus the square root of 2500 minus 1200, 1300, all divided by 2. And if I wanted to split this guy up, I would get 50 plus rad 1300 over 2, and 50 minus rad 1300 over 2. Now, after computing these in the calculator, I do believe they actually want you to round to the nearest whole number. What you end up getting here is you end up getting 6.9722 if you put it in the calculator. And I'm going to go ahead and round that up. That's going to be rounded up to 7. That's what they wanted me to do. Apparently, they wanted me to round that to the nearest whole number. This number is going to be 43.0277, which I'm going to round down to 43. Now, you might be asking yourself, how is it possible that we have two answers? Is one of them wrong? Well, sometimes we do get into this idea of an extraneous solution, and the next problem will have that element to it. But this one, I don't believe has the extraneous solution. And the reason why is because you're just trying to encapture 600 square feet. It didn't say I had to encapture it in a certain way. So if you look at these two answers, what this is saying is that one of the dimensions has to be 7. So y equals 7. In other words, if I look back at the diagram, this diagram actually looks really in line with y equaling 7. How do I know? It's because these sides are pretty short compared to this long side. So I could have a length of 7 on either side. And then since I know that x is equal to 100 minus 2y, because we found that out earlier on, I can then say that x is equal to 100 minus 2 times 7, which is 100 minus 14, which is 86, which means the first fence situation, so I'll say fence 1, could have dimensions of, looks like 7 by 86. And that could be one option for a 3-sided fence that encaptures 600 square feet. Now the other situation here, when y is equal to 43, I'll go and draw that out right below it. If y is equal to 43, hopefully it makes sense that the lengths would be longer and the width would be shorter here, right? So with this thing being 43 on either side, now you've got 100 minus 2 times 43, which then gets you 100 minus 86, which would be 14. So what you have on fence option 2 here would be a 43 by 14 foot fence. Again, they didn't say which one she preferred. All we need is that it needs to encapsulate 600 square feet, and it does under both circumstances. Hopefully that problem makes sense. I will be back with the next one. All right, in problem 5-109, it talks about Karen driving straight south on Interstate 405 on the Santa Monica Freeway interchange going 10 miles per hour faster than Melinda, who leaves the same interchange going straight east on Interstate 10. It says after 1 hour, they are 108 miles apart, measured by a straight line drawn between them. How fast is each driver going? State any assumptions that you make. Okay, well, any assumptions that we make, the first one is that they're both going at constant speed. And so I think that's a pretty big assumption we need to make. But again, this is just a model. We're not in a class that models variable speed right now. We're in a class that models constant speed, so we're good. So from here, we know that Karen is driving 10 miles per hour faster than Melinda. The problem is we don't know how fast Melinda is driving, but that's okay. We know that Karen is heading south, and we know that Melinda is heading east. Now, a moment ago, I mentioned that we don't know how fast Melinda is going, and that was okay. It is okay, because if we don't know something in math, we just call it an unknown variable, like x. And so let's see if we can figure out how fast Karen is driving with respect to Melinda. In other words, from Melinda's perspective. So if Karen's driving 10 miles per hour faster, that means that if Melinda's driving 50, then Karen's driving 60. If Melinda's driving 70, then Karen's driving 80. And if Melinda is driving X miles per hour, Karen must be driving X plus 10 miles per hour. Now, at this point in time, they did say that they were, after 1 hour, 108 miles apart and separated by a straight line drawn between them. And I hope we recognize the shape that is right there, because the way we're going to solve for x is our good old buddy, the Pythagorean theorem. And we're going to set this up. X squared plus x plus 10 squared equals 108 squared. And I'm going to say x squared plus, do not make the mistake here, this does not equal x squared plus 100. What it really equals is x plus 10 times x plus 10 equals 108 squared. And I will FOIL out the 108 x plus 10 times x plus 10. That's going to become x squared plus 10x plus 10x plus 100. So what I've got is x squared from the guy who carries over plus the other x squared plus 20x plus 100 equals 108 squared is 11664. Again, that's just a calculator. So let's go and combine some like terms here. These guys will combine out. So I got 2x squared plus 20x plus 100 equals 11664. So what I'm going to do is I'm going to go ahead and divide everything by, I'll go and divide everything by 2. Actually, no, I'll go ahead and subtract 11664 from either side. So what I get is I got 2x squared plus 20x minus 11564 equals 0. And now, because I've got even, and 0, just like the last problem, I'm going to divide everything by 2. And again, there's no need for that, but really working with those smaller numbers just makes your life easier. So what I've got is x squared plus 10x minus 5782 is equal to 0. Even if this guy was factorable, I probably wouldn't want to try to factor it. You know, guessing and checking and trying to find out two numbers that multiply to 5782 and add to 10 at the same time, it's going to be pretty tough. Again, we've been doing the quadratic formula a lot, so I guess I'll go ahead and do that. So I got x equals negative thing plus or minus the square root of a thing squared minus 4 times 2 things, all over 2 times a thing. I'm going to go and extend my square root out. From this guy's perspective, A is equal to 1, B is equal to 10, and C is equal to negative 5782, and I'm going to need more space on that third bracket right there. I'll go ahead and make that. So let's plug the stuff in. 10, 10, 1, negative 5782, close bracket with a 1 here. Again, the quadratic formula is pretty simple. As long as you know the formula, you just plug the stuff in. So x is going to equal negative 10 plus or minus the square root of 100. Be careful. This is a negative 4 times negative 5782, which is going to become a positive 23,128 all over 2. And then that's going to be negative 10 plus or minus the square root of 23,228 over 2. And now I will go ahead and split my answers up. So negative 10 plus rad 23,228 over 2, and negative 10 minus rad 23,228 over 2. Now, let's go ahead and decimalize these answers here. So this one is 71.20, and this is negative 81.20. So let's talk about extraneous solutions for a second here. An extraneous solution is an extra solution that that is not needed in the answer, or it is not needed in the problem. it makes the problem undefined, or it makes the problem go weird. So ordinarily, if I was just to have you solve a regular quadratic, both answers would totally be valid, because again, we're looking for the x-intercepts of a parabola whenever we do the quadratic formula, and we're looking for the zeros of that function, right? But remember, in the context of this problem, we're looking for speed, right? And so we're looking for a person's rate of change as they go down the highway. With that in mind, how can a person be going negative 81.20 miles per hour? I just don't think it's possible. Even if a person was going in reverse and almost hit somebody, no insurance accident report would say the person was driving negative 81 miles per hour. It just doesn't happen. Speed is what we call a positive vector, which means the negative 81.20 in the context of this problem is an extraneous solution that we don't need. 71.20 is the answer that we're looking for, which means Melinda is driving 71.20 miles per hour, and Karen is speeding away at an 81.20 miles per hour. So hopefully that problem makes sense. I'll be back with the next one. The St. Louis Gateway Arch problem. It says arches are not parabolas, but sometimes an arch can be modeled with a parabola so that we can make certain predictions. It says Ramon's company has been hired to set up a concert stage approximately 15 feet from the base of the arch. One of the bands will be performing using a 30-foot tall guitar as one of its props, and Ramon is worried it will not fit under the arch. So he adds a coordinate axis to the drawing above the model to the Gateway Arch, where both x and y represent the distance in feet, and the origin is directly below the arch's apex. He knows that the arch is 630 feet wide and 630 feet tall. Let's write that down. So this distance here is 630, and we know this distance here is also 630. And so we have to figure out if he should be worried or not. So we have to write a function that models the height of the arch. So I'll go ahead and redraw this parabola so that it looks a little bit more math-like. The arch looks like this. With the St. Louis Arch being 630 feet tall, I can call that coordinate safely 0, 630. And then the x-intercepts here, I can safely call those 315, 0 and negative 315, 0. And so now from here, this is going to help me write the equation of the arch. So we've been in this situation before, where if I have negative 315, 0 as my 0, that means that x plus 315 is my factor. And then that means that if 315, 0 is my other 0, that means that x minus 315 is my other factor. Now, because I'm actually trying to find the function of a specific parabola, I'm going to need to make sure that I include the a part, the stretch factor, in the equation here. So I'm going to go and multiply those guys out. And luckily, it's a difference of squares, so the 315s are going to cancel each other out. So I've got x squared minus 315x plus 315x, and then minus a big number here. I believe this number is 99225. And so what I'm going to get is I'm going to get x squared minus 99225 all multiplied by a, and that's my function of the parabola. So how do I figure out the a value? Well, this is why we have our y-intercept here. This is going to be 630 equals a times 0 squared minus 99225. 0 is going to be 0, so what I have is negative 99225 times a equals 630. Divide by negative 99225, and what I have for my a value is going to be negative 0.00635. So my actual equation is going to be, actually I'll write it down underneath here, is y equals negative 0.00635 parentheses x squared minus 99225. And that is a right there. We just found the equation that models the St. Louis Arch. That way we can figure out the distances and figure out if that 30-foot statue is going to fit underneath the base. So from here it says, how tall is the arch 15 feet from its base? Should Ramon be worried? There's a couple of mistakes that can be made here, and I want to warn you about them. 15 feet from its base. Here is the mistake that's going to be made. You're going to say, all right, I'm going to plug in 635. I'm going to plug in 15 into, into the equation. Here's the problem, is if you plug in 15, that 15 is right here. And of course, it's going to clear it completely. However, the band is going to be playing 15 feet away from the base, which means the band is not performing where the yellow is. It's performing where the blue thing is, 15 feet away from the base. What does that make the X value at that point in time? That makes the X value worth 300 because you're actually 300 feet away from the origin, but 15 feet away from the base. So what you have in B is not the yellow thing, but what you have is this blue thing, which is negative 0.00635 times 300 squared minus 99225. And so now what you get after all this mumbo jumbo is done, this is just calculator work here, you'll get 58.58 feet. And because the statue is 30 feet tall, I believe he has nothing to worry about. The statue will fit. No problem. In C, they ask you the final question, which is, what is the useful domain for the St. Louis Arch? Now, ordinarily, a parabola has a domain of all real numbers, but I don't think that's going to happen this time because this parabola starts and stops on the ground. So I believe an appropriate domain would be from negative 315 to regular 315. And I think you'll include x on those. So I think that's an appropriate domain for this thing. And I think that will wrap up this video. Again, summary of this video, seeing a quadratic relationship that otherwise you might not see. We saw one happen with the area of a fenced-off area, with a fenced-off deer trap, and then we saw a Pythagorean relationship that involved the quadratic formula. And this one was probably the St. Louis Gateway Arch is probably the most obvious because it's shaped like a parabola, but that's okay. I think that will wrap it up for this lesson. As always, please leave comments or questions in the comments area, and I will see you all in the next episode.